Right, this is our notes on calculating balanced forces. So I'm going to just go through this quickly and kind of explain as I go. Unfortunately, you won't be able to ask questions, but honestly, I think you got this. The first thing is we want to do is identify the object of interest, just like we've done before. We're going to circle that box. Draw the force diagram for the object and construct the XY table. So here I've got a tractor has a rope tied to a 20 kilogram box and pulls it with a force of 100 newtons while moving at a constant speed. So my force diagram, I'm going to have force normal, force of gravity. In this direction, because the tractor is pulling on a rope, so it needs to be traveling in that direction, this is going to be my force of my tension force, because we have a rope. Going back this direction, we've got our force of friction because it's moving at a constant speed. Constant speed means that this is balanced, so these have to be even. It's not going up or down, so these have to be even too. In my x direction, I'm going to have the force of friction equal to the force of tension. In the y direction, I'm going to have the force normal equal to the force of gravity. And the reason why we know it's balanced is because it's constant speed. So this is the same thing that we've done before. Nothing new there. Now we're going to start calculating all the forces at So when we're doing this, we want to put down what our formula is. So it's a good thing to kind of start with the force of gravity, because that's something that we always have the formula for. Force of gravity is going to be equal to 9.8 newtons per kilogram times the mass. So if we know the mass, we can figure out what that force is going to be. So I'm going to substitute in my numbers. I know what the mass is. It's a 20 kilogram box. So that's what I'm going to need for this one. So force of gravity is going to be equal to 9.8 newtons per kilogram. I'm going to multiply those together with my mass, which was 20 kilograms. Now, before I even put this in the calculator, I'm going to make sure, and I'm going to cross off my units. So kilograms is going to cancel with kilograms, so newtons will be the answer for my force, which makes sense because we're going to measure force in newtons. So 9.8, let me get my calculator here, 9.8 times 20 is 196. So the force of gravity is going to be equal to 196 newtons. Now let's look at our x and y tables. If I know the force of gravity is 196 newtons, then I also know the force normal. So force normal is going to be 196 newtons, and the force of gravity is 196 newtons. Let's go ahead and look at our other force pair, and that's going to be the force of friction and the force of tension. So I'm going to go up here to my question, and it tells me it pulls with a force of 100 newtons. Well, that tractor is pulling on the rope, so our force of tension is equal to our force of friction. So force of friction is going to be 100 newtons, which is the same as our force of tension. So why these diagrams are so important, because I can actually figure out every single one of my forces. Force of friction is 100. Force of tension is 100 newtons. Force of gravity is 196. Force of normal is 196. Now we're going to change things up just a little bit here. If the box experiences a 98 Newton normal force, what would the mass of the box be? So again, we're looking at a normal force here. So my formula is force of gravity is equal to 9.8 newtons per kilogram times mass. Same formula I used before. Now, I know that the normal force is the same as the force of gravity in this case. So we can kind of do this. So I'm going to substitute my numbers in. So 98 newtons was my force normal. 98 is equal to, I'm just substituting these numbers in, newtons, kilogram. And I'm going to be solving for mass. Now the first thing I'm going to do is I'm going to look to see, do I have any units I can cross off before I even handle the numbers? Well, I can see I've got Newton here and Newton here. My unit to end with is going to be mass. Now remember Algebra 1, way back when, I need to isolate my variable. This variable needs to be on one side of that equal sign. So I need to get rid of the 9.8. Remember in algebra class, if it's multiplication, these two numbers are multiplied by each other. To get rid of the 9.8, I need to divide it by itself. If I do it to one side to get rid of it, I'm going to do the same thing to the other side. So now my mass is going to be equal to 98 divided by 9.8, which is 10. Now your unit is going to be the only unit that's left over, kilograms. So my mass is equal to 10 kilograms. Now, if we count for drag, remember drag would be the force of friction, drag would be the force of air pushing on our box. So if we're looking at our drawing here, it must be that this tractor is moving pretty fast. The air is coming here, hitting the box, which is causing a force of drag. So as if we account for drag, what would the drag force be if the friction force was 72 newtons? So our friction force is also going in this direction. So now we're going to add in drag. I'm going to add another little arrow there. It's still going in the same direction. This is our force, our drag force. So our friction force is, so let's just do this in symbols. Our force of friction, let me change colors here, is plus our drag force is going to be equal to that force that is pulling in the opposite direction, which was the force of tension. So now I'm going to go ahead and substitute my numbers in and calculate the drag. So my force of friction is going to be equal to the force of tension. So my force of tension is 100 newtons. The force of friction, my question tells me, is 72 newtons plus my drag force. So in order to solve this, again, my newtons are going to, we're adding these together. So my answer is going to be in newtons, because this plus this equals that many newtons. So in order to get rid of to isolate my variable, we have two numbers that are being added together. So the process I'm going to need is to subtract this from this side. That gets rid of that. If I do it to one side, I'm going to do it to the other side. So the force of drag is going to be 100 minus 72, which is 28. We're just adding things together, so it's going to be 28 newtons. So the force of drag is equal to 28 newtons. Here's my final answer. And that's the end of the sheet.